Today I am going to show you how to use GeoGebra, which is a great software to utilize in any 6 through 12 classroom. GeoGebra is easy to access from the internet. Simply type in GeoGebra into your browser. This first link right here will bring you right to their website. Once you access the home page of GeoGebra, you will notice that there are many options. The two primary features involve graphing, which you see right here, the purple button, and classroom resources in white. I will walk you through both of these options. We will start with the graphing tool, so I'm going to go ahead and select this tool right here. And that will open the graphing calculator tool. This feature provides students and teachers with many options. This tool is primarily used as an additional resource. Students can use this graphing calculator similarly to a handheld graphing calculator. Students can simply type in a function to view the graph. For example, I could type in a trig function, so I'm going to go ahead and type in y is equal to sine of x. And we see the sine function displayed as a graph right over to the right. So over here we see the function itself written as an equation, and over here we see the corresponding graph. Now I could go ahead and type in a second function and have both of them displayed on the same screen. So I could type in y is equal to sine of x again, but this time I'm going to do plus 1. So it shows me the green, the original equation, and the graph, y is equal to sine of x, and the blue graph, y is equal to sine of x plus 1. So students could use the graph of the two functions to determine that adding a number to the end of a function, like I did here, the plus 1, would result in a vertical shift. So we can see that this was the original function, the green one, and the blue, we added the plus 1, results in a vertical shift. So that's one feature. You could just type in functions and view the graph. Excuse me. There are also features that are not typically found on traditional handheld graphing calculators. So for example, most graphing calculators we could have done the same thing, type in two different functions and view their graphs. But there are other features that we would not typically find. So I'm going to go ahead and delete this just to show the next option. So one example is I could type in y is equal to ax plus 2. We'll do for an example. And as you could see here, a button comes up that says create slider. So instead of typing in a number for slope, I typed in a instead, as you could see. So students could use this graphing feature to explore slope, which aligns with the Common Core state math standards for the 8th grade functions. Students will be able to use the functions to model relationships between the quantities. So as I was saying, what I did was I typed in a instead of a number. So a is representing the slope, and as you could see, a slider is now displayed once I selected that create slider. So I could adjust the slider, and as you could see, when I move the slider, it adjusts the slope. So it corresponds to the number here that I have on my slider. So say I want it to be a is equal to 2. I still have a y-intercept of positive 2, but now my slope is 2. So I can see that line and how that line is represented on the graph. But I could do negative 2, and now I see a negative line, which corresponds to the negative 2 that I put on my slider. So it's more of an interactive tool that students can use in order to really dive in and explore why certain mathematical concepts are the way that they are. This also aligns with the ISTES standards. specifically 5C for computational thinkers. Students break problems into component parts, extract key information, and develop descriptive models to understand complex systems or facilitate problem solving. So I think this example right here with the slider is a great example of that. We could traditionally just plug in different slopes on a graph and view the different graphs just like I showed you before with the sine functions, but here they're actually able to adjust them and view them in real time as it's changing, which I think is a great feature. The second portion of GeoGebra involves many classroom resources. So I'm just back at the GeoGebra home screen, and I'm going to go right over here where it says Classroom Resources, and I'm going to go ahead and click that. So as you can see, there are many resources that involve mathematical topics. GeoGebra primarily focuses on math, but there are other topics as well that different contents could use. So right on the top of the screen, we see that there are various topics that we would see within a 7 through 12 classroom. So students could either select one of these topics, for example, functions, and then scroll down to view one of the many classroom resources associated with functions. Now, students could also come right up here to the search engine and simply search for a specific topic. So, for example, I could search for a resource that focuses on slope. So, graph the line, for example, relates to slope. So at this point, you could either pause the video to explore one of the many resources associated with slope, or you could select the resource that I'm about to select. So now that that loaded, I'm going to select this first one right here, graph the line. Now, as you can see, there's a title, the author, and different topics associated with this resource that was selected. So many of the resources have a set of directions. So this one, for example, says drag points A and B so the line matches the equation. So we're given a line and the equation. So y is equal to 4x, so I can move my y-intercept and my second point in order to correlate to the slope. So once I have the answer correct, the line changes color and it tells me in big bold letters I did it. And students could use this as an interactive approach to learn about slope. They could just select new line to get a new line, for example. Y is equal to negative 2x minus 2. So I can drag my B once again to get my y-intercept and drag my second point in order to correlate the slope. So that's just one resource, for example. Now, if I come right back up here where it says GeoGebra, I can select that to go back to my home page. And as I mentioned earlier, there are also many resources available within other contents. For example, science, physics, social studies, and art. So for social studies, for example, I'm going to type in Know the States. This is just a resource that I found prior. So Know the States is basically a resource, as we're waiting for this to load, that would work within a social studies classroom. Essentially what it does is, now that this loaded, it's this one that comes up right here. We see that we are given a map and every state with a different point. So students can view the state that they were given, find it on a map, select that state to see whether or not they're correct or incorrect. Now, there's also another great one that I found for science, which is bacteria growth. So I'm, again, just going to type that into the search engine. And let's see. I may have to go to my saved, find that one a bit quicker. So bacteria growth is an experiment with changing bacteria type and running the animation. So basically, I can select animate and it shows right over here as the days increase, the amount of bacteria increases as well. Now I could select which types of bacteria I want to view. And I can also come right over here and there's a corresponding graph. So it's just another great resource for science that shows the real life application and shows how the bacteria is growing over time. So I thought this was another great example for science.